I'm here to talk a little bit about cloud and blockchain, specifically cloud, blockchain, and how we are going to connect the two and optimize digital and physical resources for the future. A little bit about my background real quick. Maybe the gray hairs on my chin will testify. I've been in the space for quite a while. I was at Red Hat for over 10 years, working under Linus Torvalds. So if any of you send network packets over a network or store data on a hard drive or an SSD, you're running my code. Or if you have an Android phone, you're also running my code. How many people have Android phones then? All right, all right. A lot of iPhone users here. We'll forgive you this time. And then in 2010, I found blockchain. I was the third most prolific developer after Satoshi Nakamoto and his number two, Gavin Andresen. So I've been in the blockchain space for almost 10 years as well. And having been involved in those two in particular, I'm really sort of seeing a fusion where cloud and my earlier Red Hat experiences are starting to merge with blockchain. And I'd like to tell you a little bit about that today. About Block, my company, is we have two sides of the house. One is Block Labs and the other is Block Enterprise. And these two feed into each other like the infinity symbol seems to imply, is that enterprise, they move slowly into innovation. They're very risk adjusted. They need SLAs, IP and patent guarantees, and in general, very high availability. They're not going to be on the bleeding edge. But at the same time, you need to generate that innovation. You need to, like Bell Labs or Xerox PARC before it, create the innovation and then field test it, real money test it, battle test it so that it's ready for the enterprise. And that's what Block Labs does, is we introduce new bleeding edge innovation onto the market, creating tokenized networks and applications. And then on the back end, we sign up customers such as Discover to envelop and absorb the new blockchain, new tokenization strategies into their enterprise. So those are the two sides of the house, the two business units of Block, and really driving what's why I'm here today. So today I'm going to focus on two key themes: is what's next right now, short term, and then what happens after what comes next. Is today we have, and I'm going to talk about unlocking multi-network or cross-blockchain potential with cloud. And then tomorrow is, what does the next version of cloud look like? How do we move beyond REST API calls into a deeper paradigm? So at Block, if you poke any Block employee hard enough, they're going to blurt out multi-chain, multi-network, multi-token. Now, what does that mean if you're not in the blockchain space? Is that there are a number of different technologies, the Bitcoin, the Ethereum, the XRP Ripple, Tezos, the list goes on and on and on. And these blockchains, although very similar, are not perfectly interoperable or compatible. Another aspect of blockchain is decentralization. As to many purists, decentralization is just an article of faith. These purists have very loud voices, and for various reasons, they tend to talk in absolutes. But this is a nascent marketplace. In a crowded information environment, it's very easy to kind of mistake visibility for leadership. But the practical reality of blockchain adoption is going to look very different. It's kind of more like a dimmer than an on-off light switch. Blockchain and decentralization is going to be slow. It's going to be stepped. And each one of these steps gets us closer and closer to that goal, but it's a long journey. It's not just you're centralized or you're decentralized. There's an entire range to consider in terms of servers, networks, block producers. There are many developers. There are many aspects that are centralized or decentralized to look at across the medium. So the first question I'd like to explore is, how do we bring that first million blockchain developers? Well, I would do the following three things. First, blockchain skills are definitely very rarefied. I would definitely leverage the skills that developers already have. You know, we want to leverage cloud computing paradigms, i.e. AWS, that's already very well understood, and that's the way we do business today. And then finally, let's take analysis paralysis away by considering one API across many networks. So if y'all are familiar with computing history in the past, we have an example, Twilio. Before Twilio, as many developers will remember, if you wanted to talk to a T-Mobile phone, you had to code to a T-Mobile API. You want to talk to a Verizon phone, you had to code to a Verizon API. You might remember when you're booking airline tickets, you had to tell the airline, if you want to SMS me, I'm on this mobile phone network. That's under the hood, why? Then this business Twilio came around, and they solved everything by saying, just come to us. We have one API that talks to all the mobile phone networks. So that's our history. And specifically, blockchain development, as we're applying that Twilio pattern, should require less attention paid to network selection, should bring more developers into the fold, and ultimately, we don't want you to have to think so hard about infrastructure concerns. You should just be able to start coding. Fundamentally, that's what AWS introduced in 2006. If you want a server, as my computing past, I was just relating a story earlier. Back in my past, I helped run an ISP, and if we wanted a new server, you physically went and got a bare metal box and plugged it in, and then you could spin up an application. AWS came along, all you had to do was hit an API and you have 1,000 servers. We want to bring that type of infrastructure, that hit an API and go type of picture. And for that, in the service of inclusion, the cloud paradigm is absolutely essential. The tools that we need to build the bridge between today and tomorrow, they're right in front of us. They're widely available, they're not all that expensive. Enterprises are already familiar with these tools, cloud computing, managed services, and so on. Enterprise teams should be able to take the skills they already have and deploy them in the service of new blockchain applications. Further, and this is very key, blockchains are fundamentally an ever-growing data set. These are some of the largest hash databases in the world. And as a result, that places real pragmatic costs on the demands of computers in terms of increased data storage, lower seek latency. For example, rotational hard drives are persona non grata because the seek latency is so high that you have to use SSDs with certain blockchains. Keeping up with the demanding blockchains such as Ethereum requires ever more compute, data storage, and memory resources. And that becomes a management challenge. And we've seen this in the crypto industry, is you first step is DIY. You build these nodes, you build these blockchains yourself, and then you realize, hey, I'm spending a lot on DevOps, and this is not my core focus of my business. And so I need to look at someone else managing this for us while still giving me this full, unabridged, neutral network access across all of these protocols. And so, in the service of this, we've introduced the product BlockCloud. BlockCloud is an initial set of services, the first of which is at the bottom left is nodes. This is a blockchain node on top of a virtual machine that provides instant up access for across many different networks. Now, you're thinking, well, I can just hit a EC2 API and spin up a virtual machine. Why is that a big deal? Well, Ethereum, EOS, and some of the other blockchain networks literally take weeks to go from zero, what's called the Genesis block, to the database is fully in sync, merged, and ready for action. 2 weeks. And we have, in particular, turned to AWS for some of the solutions that enable building that product. EBS snapshots in particular were critical for giving us a from zero to you have a fully working running Ethereum node time keeping that absolute to the minimum, we have a continuous process that utilizes EBS snapshots and cross-region migration in order to save, again, literally weeks of database rebuild time. We use S3 quite extensively, as just about everyone else does. And we use, pretty creatively, Route 53 and SSL in terms of if people are familiar with DNS and certificate chains and roots of trust. There's a feature in DNS called DNSSEC that helps create a root of trust that you can use as a digital root of trust from the AWS platform through our platform all the way to your individual node. And so that chain of digital security, that chain of digital trust, is something that the AWS custom CA enables and we're using. Also, we use Elastic Beanstalk and plain old EC2 quite a bit. That's the nodes product. Under the hood in Connect, this is a data-driven API. Connect is on a blockchain what you use after you're tired of running nodes. You say, I need more indexes on top of these billion record data sets. I need quick access to these billion record data sets. And again, we turn to AWS. And following the serverless trend, this is first stage is AWS Lambda. Second stage is goes to a set of regional Elastic caches, such that, for example, if you're in Singapore or Beijing, you don't need to go all the way back to America to request data. You're going to a regional cache, which has the most recent public blockchain data, fully indexed, highly available, high throughput availability. And that was very key in order to have instant cross-region, cross-geography availability of this product, getting us down to millisecond latency for our queries. Again, we're dealing with billion record data sets. This is not something that you can just spin up. It's sadly even not very well compatible with, say, Cassandra or Redshift or some of these others. These hash databases are so highly specialized that we had to build special caching and indexing to make it performant. And then finally, the spot instances were another key component, such that now that we're using EBS snapshots as the basis for our node service, this enables us to look at where are the regions which are most economical to provide extra node capabilities. Those, again, virtual machine-like managed instances. And EC2 spot instances cut our cost by it's 60%, 65, 70%. And we're able to pass that cost savings on to consumers. And so that's what BlockCloud is today. And the long story short for BlockCloud is that if you're building a blockchain application, what you're looking for is not the current out in the industry balkanized, siloed, tribalized set of APIs. Again, going back to the Twilio analogy of if you want to talk to Bitcoin, you're going to use this API. If you want to talk to Ethereum, you're going to use this API. Tezos, this API. We built something that's a one-stop shop. So what's next? What's next is tokenization. So for those that are unfamiliar, tokenization is creating a digital representation of one's ownership in whole or in part of an asset. That can be a physical asset, like a car, a boat, some real estate. That could be, in this case, a digital asset, a virtual machine, a EC2 set of resources, or a set of network resources, a set of memory resources. All of those fundamentals can be tied to a digital token. And if you tie it to a digital token, you can unlock a lot of potential from that particular asset. So, why would you tokenize? Well, very, very clearly, it marries the technology with its economics. And so the economics of a technology can be then exposed to open marketplaces. Things that were not available in marketplaces before, digital, you can trade computing, you can trade memory, you can trade network bandwidth. When you associate it with a digital token, you're compartmentalizing the actual function of the digital asset from the ownership, the use, the transfer of that digital resource. And when you separate the two, you open up markets, you increase participation, and then ultimately you bring more users, more customers into the space, which is our ultimate goal. So according to one paper, an illiquid asset, for example, trades at a 20% discount versus a asset that is fully liquid, available on peer-to-peer marketplaces, and can be traded, sold, transferred, and then finally, at the end of all that chain, delivered and used as an actual EC2 instance or S3 storage, or pick another type of cloud computing resource. So what happens when we apply this to cloud computing? So today's cloud paradigm, again, walking back to the first Beowulf clusters that I worked on pre-Amazon back in the early days of Linux, is we were using the old 1990s client-server model. I'm a client, I reach out, I call a server. Cloud is fundamentally that same model. I'm a client, I reach out, and I call a server. The server in this case is a multi-container Kubernetes instance that's load balanced across multiple AZs and et cetera, but fundamentally it's the same paradigm in terms of calling APIs and executing those resources. What we argue is that tokenization and blockchain are the new API frontier. Today, much like digital asset transfers are becoming decentralized and tokenized, the provisioning of cloud compute, cloud storage services could be as well. This leads to a new set of possibilities for exciting applications for both customers as humans, meaning, today, a customer purchases a token which is associated with a cloud computing resource, say EC2, and then I can activate an EC2 instance. Or, and this is new, customers as code. So smart contracts, these are pieces of software that live on the blockchain and are executed autonomously. These can call other smart contracts. And so we can foresee that ultimately the tokenization of cloud computing resources delivers a new economics-fueled API frontier that can serve both conventional and distributed autonomous organizations with equal ease. Tokenization unlocks the real value of cloud services and allows developers and businesses to participate in and accelerate the Web 3.0 world of blockchain-based networks. So, what is the new API frontier? Specifically, we have to dive into a little bit of smart contract for those in the audience who are not familiar with it. A smart contract, if we rewind 20, 25 years in database terms, it's kind of like a stored procedure. Is you generate some software, the source code, you compile it, and then you deploy or push it to the remote service. Once the software is deployed, similar to deploying a Lambda at AWS, you wait for that trigger. And the trigger, or the API call, is coming from another smart contract on the blockchain. That may be a user, an individual person who indicates, I need to move this token, I need to call this procedure. That may be another smart contract, which is running an organization, such as a lights out robo-investing type use case. And so ultimately, we'd like to divide it into two categories: composability and financialization. Composability example is that when you're deploying a smart contract, you're creating a Lego block. A Lego block, a module that other people, anyone in the world, can call when they build another Lego block. So building an application, a blockchain application, involves many of these Lego blocks, and one or two of those Lego blocks is going to be, say, EC2 run a virtual machine type smart contract. So why would you want to do that? Well, if you have an organization that is already on the blockchain, it's running most of its cap table, its balance sheet, its operating expenses, its capital expenses through this blockchain software, then you are automatically able to call out to any AWS resource and allocate that on behalf of that business. So this adds AWS as a foundational element, foundational module in a big, big ecosystem of autonomous software. That's composability. You can compose multiple modules on the blockchain to deliver software components. Similarly, financialization is probably what many people have heard about in terms of cryptocurrency and markets and trading, is that once you have a resource, such as a virtual machine associated with a token, you can not only trade that, but you can start to do some really advanced financialization in terms of derivatives. Specific example, if I'm a business and I know that I'm going to run a large batch process, I'm going to run all of my accounting reconciliation, once every quarter, I need a lot of EC2 instances to run that. Now, I know ahead of time that I need 1,000 EC2 instances. If the resources are tokenized and on a market with futures and derivatives, I can look forward and say, okay, I know I need this resource 6 months into the future, 12 months into the future. I can buy that now and then have it delivered exactly when I need it. And I'm participating in a fluid-free market exchange for those tradable assets. Other financial players will see that activity in the market, and they might speculate and they say, well, there's a lot of resource over here that's sitting unused. I'm going to buy those tokens at a cheap price. And then when the big accounting firm needs to run their batch process, I'm going to sell those tokens to the big accounting firm for a profit. And so this injects liquidity, this injects volume, and ultimately, with more market participants and more tokenization of cloud resources, that generates more users, more use, and obviously for BlockCloud and for Amazon, more business. So we talked a little bit about composability. This is clicking for detail. It's the modularization of units of cloud service into easily assembled components. Via tokenization, cloud resources can be built directly into decentralized applications and access in an entirely lights-out programmatic manner. Powerful services and applications can be built on top of tokenized cloud resources and easily swapped out for other building blocks as required. That really tight modularity that enables you to say, oh, okay, I'm just going to plug this into the stack. Obviously, we have the concept of modules, modularity outside of blockchain, and this brings AWS, cloud, et cetera, into the new millennium of blockchain and resources. On the financialization side, as cloud computing becomes more composable and more easily swapped, like we talked about in the last slide, an application can more intelligently switch between various services based on its requirements, such as speed, latency, capacity, et cetera. If there is a free-flowing market for cloud resources, then we actually introduce an element of competition. And we can say, well, over here, there's a better deal for cloud resources than over here. And since all of these are programmatic modules, we can automate the process of seeking a competitive bid for cloud resources. So we're moving up the stack beyond just, I know I need to buy some VMs, to competition, automation, and ultimately sort of that lights out autonomous behavior that blockchain brings. So you can almost imagine a day when CNBC or Fox Business is saying, today in cloud futures, or The spot market for cloud computing spiked briefly today on news that corporate America is investing more money in outsourced infrastructure, et cetera, et cetera. That is what financialization of cloud resources can bring, is an application can intelligently procure the resources and infrastructure it acquires autonomously. So what if cloud resources, as described, were tradable assets? Now we have a marketplace for these cloud instances, and they can trade those as needed. What if the usage of tokenized cloud resources? In this model, the resource customer purchases a so-called NFT, or non-fungible token. This means that in contrast to, as you may have heard of, an Ethereum coin or a Bitcoin or something like that, those are interchangeable, just like your dollar is worth the same as my dollar. They're fungible. They're equally interchangeable. A non-fungible token is a digital asset that wraps in digital signatures and digital security that resource. And so unlike dollars, one unit of this token cannot necessarily be traded for another. And this represents, for example, an EC2 instance with the specific characteristics that you see here. This token is deposited in the customer's wallet. A wallet is, for those unfamiliar, it's a key management system. It manages private keys and signs and approves actions. And then later, this user might decide it's time to spend that resource. This token serves as a kind of deed for that EC2 instance. If the user is a shrewd buyer, then he or she may have purchased this at a time when it was less expensive than the spot price at the time he used it. So you can save money by planning ahead, tokenizing, and utilizing liquid markets. These benefits, excuse me, the two features deliver powerful benefits. First, the value of these components is determined by the market. It's as fair as possible. Composability means that increasingly complex systems can be built, but the process of meeting that complexity is far less intimidating. You can deliver microservices more rapidly, and you can ultimately achieve more powerful network effects because your users can include these autonomous entities as well as human participants. So ultimately, we're continuing to explore the tokenized cloud computing future. Now is the time to advance tokenized protocol development. We're determining the marketplace dynamics for introducing these tokens. And ultimately, this is all building a future for cloud computing. Today, you make REST API calls, and tomorrow, smart contracts that you write for your business application will call other smart contracts to allocate resources in a liquid, economic-linked network. Thank you very much, and I'd love to take some questions.
So I'm just thinking of scenarios where you have so today in the banking industry, if you have like a card present transaction, it's of lower risk as opposed to a card not present, right? So how does blockchain, tokenization, yes, that's already there, but how does blockchain address those kind of concerns?
Sure. So specifically with the cards, those actually have these digital tokens on them. And so we can directly secure the digital tokens on your card using the same techniques as we're using in the blockchain. It's basic digital signatures. And once you have the chain of trust for digital signatures, you can say, Jeff, sign this over to maybe you. I just sent you $10. And then you check that digital signature and validate that it was correct, that the balance has not been double spent. I didn't give the same $10 to 20 other people, which is the fundamental problem that Bitcoin and these other networks solve, this double spending or data copying problem. The blockchain is, as some people say, one of the first technologies that is actual working digital rights management. It guarantees there's one and only one copy of a digital asset. And so that's the unique part that blockchain introduces on top of these existing digital signature technology. So the chip and pin is actually an example of the same technology we're already deploying in blockchain, and that's bringing that same security to outside the blockchain card networks. I think the next step beyond that is going to be an element of digital identity. And so people are looking at digital passports, decentralized identities, and being able to securely prove that I am who I am. That's another aspect of this. And so all of that centers around just broadly the blockchain category, but I'm happy to drill down deeper into the specific technologies if you want.
Hi, QLDB and DAML seems to provide like a very easy smart contract like framework and language, and it's open source in a sense, right? Is that something that you might also consider adopting into your frameworks as well and helping push that standard, or?
Well, the short answer is yes. Very definitely. We're already integrating both QLDB and some of the other private blockchain networks. But what we're focusing on is these public networks right now. So the enterprise customers, they're looking at closed networks first. We kind of saw the intranet to internet flight path, and QLDB, Tendermint, and Hyperledger are all playing in that same space. But what happens when you need to interconnect from QLDB to quote unquote the internet, the public networks? And so that's when you start to look at cross blockchain. How do I secure on blockchain A and then hop over to blockchain B? So QLDB is absolutely in the picture, and that's something that we definitely want to expose to customers. But at the end of the day, it's still your own little private pond. And you'll have to reach out from that private pond to the public networks, and that's your Bitcoins, your Ethereums, your EOSs, et cetera. Now, I mentioned enterprise earlier. Enterprise wants to kind of risk adjust as much as possible. If you talk to a Fortune 500 company as we do, they are very interested in QLDB and Hyperledger and Tendermint and similar technologies, and they're just getting their feet wet. But once they want to make that leap, they're going to have to interconnect with other networks. And the public blockchain networks, their function is sort of a neutral referee, a neutral playing ground, where if you're interacting with another person, another entity on that same public blockchain, then you know that you're both playing by the same rules. And there's no sort of JP Morgan ring fence around the entire network where there's a different, maybe hidden set of rules applying to that network. And so having the term is a single source of truth, that's one of the values that the public blockchain networks bring that the private blockchain networks are still trying to sort out. So it's a bit of a complex answer, but the short answer is yes, we're absolutely looking at QLDB. Yep, atomic swaps, and another feature is wrapping, where you have one token, say Bitcoin, on the Bitcoin network. I create another token, which is a representation of that on Ethereum called wrapped BTC, and that's a fully digitally secure representation on blockchain B of an asset that's on blockchain A. So it's not a swap, it's you put some BTC in what's called cold storage, and then you warm it up over here on blockchain B, and they're securely linked through digital signatures between the two blockchains.
All right, so are you thinking that this is going to be a foundation for cryptocurrency across multiple large organizations? That it's going to be something that bridges the gap foundationally?
Fundamentally, that's our BlockCloud product is bridging that gap. And so we see a number of different networks. And in the early days of blockchain, both public and private, it was balkanization. If you're a Bitcoin guy on a Bitcoin technology or a Hyperledger on a Hyperledger technology, and you wind up with a dozen different APIs. And that was sort of the pre-Twilio problem that I was highlighting and that we're trying to fix, is that our desire at Block is to create one API that lets you talk to multiple networks. And that's the problem that we're solving, and I think that we are solving, so that you don't get into, well, you know, I'm a fan of this, but not of this. That should never enter into a pragmatic, neutral analysis of a technology. Is I just go to this one provider, and they know how to talk to multiple networks, and we're unlocking a lot of that value as a result. So there are specializations, but at the same time, you don't need to learn 20 technologies just to compare them and then get some advice. We can fast forward that story 1000x.
How it is different from the Cosmos network built on top of Tendermint?
So the Cosmos network is for swapping tokens, going between two networks, moving a digital asset from one network to another. And we're building an integration into Cosmos. So you would be able to go through us to access Cosmos like any other network. So it's not a competitor, it's a complement, because we ultimately want to say, hey, Mr. Developer, if you want to build a blockchain application, and note I'm not saying Bitcoin application, Ethereum application, I'm saying any blockchain application, we make it easier for you, including Cosmos. So that's one of many networks that we connect to.
That includes Ripple as well?
I'm sorry.
That includes Ripple?
It does include Ripple as well. Yes, Ripple and Stellar as well. Okay, thank you very much for coming. I appreciate it. And if anyone wants to learn more, you can go in your browser to block.cloud. Thank you.